every major government building, cathedral, and important structure built before 1900 had copper domes. Not just decorative copper, massive copper domes, some of them weighing tens of thousands of pounds. The Massachusetts State House dome, covered in copper in 1802, the first building in North America to use copper roofing, the Library of Congress, copper dome completed in 1897. The Arizona State Capitol, copper dome from 1901. St. Isaac's Cathedral in St. Petersburg, copper dome completed in 1858. Berlin Cathedral, 5 copper domes installed in 1905. Hundreds of buildings across Europe, Russia, and North America, all topped with copper. And then I started asking a question nobody seems to ask. Why copper? Why not iron or steel or lead? Copper is expensive. It's harder to work with than other metals. It requires skilled craftsmen to install, and it turns green over time from oxidation, which means you lose the shiny metallic appearance that supposedly made it attractive. So why did every important building for 200 years use copper domes? The standard explanation is aesthetics and durability. Copper lasts a long time. It doesn't rust. It develops a beautiful green patina. It's a symbol of prestige and permanence. But that doesn't explain the specific engineering, because when you look at how these domes were built, you notice something interesting. They weren't just decorative shells. They were complex structures with specific designs. Grounded connections, metal frameworks extending deep into the building, copper sheets connected in precise patterns. It looks like they were designed to do something beyond just covering a roof. Let me tell you about something most people don't know exists. Telluric currents. Telluric currents are natural electric currents that flow through the Earth's crust and surface. They've been scientifically documented since the 1800s. You can measure them. They're real. These currents are caused by several things: changes in Earth's magnetic field from solar-wind interactions, electromagnetic waves from the ionosphere, naturally occurring charge differences between regions of the Earth. The currents flow parallel to Earth's surface, they have extremely low frequency, and they traverse large areas. Since the 1930s, geologists have used telluric currents for mineral prospecting. You can map underground structures by measuring how telluric currents flow through different rock types. The technique is called magnetotellurics, and it's standard practice in the mining industry. So telluric currents are real. They exist. They can be measured. And they carry electrical energy. The question is, could they be harvested? In 1901, Nikola Tesla began construction of Wardenclyffe Tower on Long Island, New York. The tower was 187 feet tall with a 68-foot copper dome on top. Below ground, Tesla installed an extensive network of iron rods and copper plates extending deep into the earth. The official story is that Wardenclyffe was designed for wireless transmission of messages across the Atlantic, a telegraph station to compete with Marconi. But Tesla's own writings tell a different story. He wasn't just trying to send messages, he was trying to transmit electrical power wirelessly. He wanted to create a global system where anyone could tap into free electricity from the atmosphere. Tesla believed the Earth itself was a giant electrical conductor. He thought by injecting high-frequency currents into the ground at specific locations, he could create standing waves that would resonate around the planet. Anyone with a receiver tuned to the right frequency could extract power from these waves. The copper dome on Wardenclyffe wasn't just an antenna. It was designed to interact with atmospheric electricity and telluric currents. Tesla wrote about using the Earth's natural electrical properties to create a fountain of electrical energy. Wardenclyffe was never completed. J.P. Morgan, who funded the project, pulled his support in 1906 when he realized Tesla wasn't just building a telegraph station. In 1917, the tower was demolished and sold for scrap. The same year, copper production in the United States reached record levels. Now let me show you something about electromagnetic induction, because this is real physics, not speculation. When a conductor like copper is placed in a changing magnetic field, it generates an electric current. This is called electromagnetic induction. It's the principle behind every electric generator and transformer on Earth. Earth's magnetic field isn't static. It changes constantly due to solar wind, ionospheric activity, and internal dynamics. These changes induce telluric currents in the ground. If you place a large copper structure, say a massive dome, in the path of these magnetic field variations, you create a conductor that interacts with the changing field. The dome experiences electromagnetic induction. Small currents flow through the copper. If the dome is properly grounded and connected to an internal conductor network, those currents could theoretically be collected and utilized. Now, how much power are we talking about? Not much. Modern research into atmospheric electricity harvesting shows that the power density is extremely low. You might generate milliwatts to a few watts from a large collecting structure under normal conditions. But what if the old buildings weren't operating under normal conditions? What if there was a global electrical environment in the 1800s that we don't have anymore? Let me tell you about something that happened in 1815. Mount Tambora in Indonesia erupted. It was the largest volcanic eruption in recorded history. It ejected 60 to 120 million tons of sulfur dioxide into the upper atmosphere. 1816 became known as the year without a summer. Global temperatures dropped. Crops failed worldwide. Snow fell in July in New England. But there's something else sulfur dioxide does. It changes atmospheric electrical conductivity dramatically. Sulfuric acid aerosols in the stratosphere disrupt the ionosphere. They alter how electromagnetic waves propagate. They change the electrical properties of the atmosphere. If there was a global energy network operating before 1815, a system that relied on stable atmospheric conditions for wireless power transmission, Tambora would have destroyed it instantly. After 1815, any technology dependent on atmospheric electricity would have stopped functioning. Buildings that were designed to harvest atmospheric energy would have become inert, just decorative domes on top of dead structures. And within decades, the knowledge of how the system worked would have been lost. All you'd be left with is copper domes that look nice and a vague understanding that copper is prestigious. Let me go back to those old buildings, because when you look at the engineering, you see patterns. The copper domes aren't just sitting on top of the buildings. They're electrically connected to metal frameworks that extend through the structure. These frameworks are grounded into the earth. The Massachusetts State House has a complex copper dome with an internal iron framework. That framework connects to metal structural elements throughout the building. The Library of Congress dome has a steel frame supporting the copper. The frame is grounded into the building's foundation. The same pattern appears in European cathedrals. Copper domes with metal frameworks extending down into the structure, grounded into the earth. It looks exactly like what you'd design if you wanted to create an atmospheric energy collector, a large conductive dome to interact with changing magnetic fields, a grounded framework to collect induced currents, metal conduits to distribute the power throughout the building. Could it have powered entire buildings? Probably not. The power density is too low. But could it have provided supplemental power? Lighting? Small electrical devices? Maybe. If the atmospheric conditions were different, if there was a stronger telluric current network. If the global electrical environment before Tambora was more conducive to this kind of harvesting, I can't prove that. But the engineering suggests it was at least possible. Now here's where it gets stranger. Because a lot of these copper domes were removed or replaced in the early 1900s. The original Arizona State Capitol copper dome was actually fake. It was turned metal, steel coated with lead and tin alloy, painted to look like copper. Installed in 1901, it wasn't replaced with actual copper until the 1970s. Why fake copper for 70 years? The U.S. Capitol dome was originally wood, covered with copper sheeting. Completed in 1829. It was replaced with a cast iron dome painted white between 1855 and 1866. They replaced copper with iron and painted it to look like stone. Multiple European cathedrals had their copper elements removed or replaced with other materials in the late 1800s and early 1900s. The official explanation is maintenance, war damage, or modernization. But the timing is suspicious. Between 1880 and 1920, there was a systematic pattern of copper removal from major buildings, sometimes replaced with other metals, sometimes with fake copper, sometimes just removed entirely. This is the same period when electricity distribution through wires became the standard, when power companies established themselves, when J.P. Morgan and other financiers took control of the emerging electrical grid. What if copper domes represented a competing technology, not a replacement for the grid, but a supplement, free atmospheric power that anyone could access without paying a utility company? What if the domes were systematically removed or replaced to eliminate this possibility? Let me be clear about what I can and cannot verify. Can verify. Telluric currents exist and carry electrical energy. Electromagnetic induction is real physics. Large copper structures will experience induced currents and changing magnetic fields. Tesla was trying to create wireless power transmission. Wardenclyffe Tower had a copper dome and was demolished in 1917. Many historical buildings had copper domes with grounded metal frameworks. Some copper domes were removed or replaced in the early 1900s. The 1815 Tambora eruption changed atmospheric conditions globally. Cannot verify. That copper domes were actually designed to harvest atmospheric electricity, that they generated usable power, that a global electrical network existed before 1815, that copper dome removal was coordinated to suppress free energy, that the power grid industry deliberately eliminated competing technology. What I can say is this. The engineering is consistent with atmospheric energy harvesting. The timing of copper dome removal coincides with the establishment of the commercial power grid, and the knowledge of how to build these structures was lost remarkably quickly. In 2022, researchers at the University of Massachusetts created a device that harvests electricity from humidity in the air. They call it the AirGen. It's a thin film of protein nanowires that generates continuous electricity from water vapor in the atmosphere. The device produces about 0.5 volts continuously. Multiple devices can be stacked to increase voltage. The researchers say the technology could eventually power wearable electronics or sensors without batteries. So atmospheric electricity harvesting is real. It works. Modern science has proven it's possible. The question isn't whether you can harvest atmospheric electricity. The question is whether historical buildings were designed to do it, and whether that knowledge was deliberately suppressed. Let me walk you through how it theoretically would have worked. The copper dome acts as a large conductor exposed to atmospheric electric fields and changing magnetic fields from telluric currents. Earth's atmosphere has a natural vertical electric field. On a clear day, it's about 100 to 150 volts per meter. During storms or certain atmospheric conditions, it can be much higher. A tall copper structure creates a potential difference between its top and ground. The dome collects charge from the atmospheric field. Simultaneously, changing magnetic fields from telluric currents induce small currents in the copper through electromagnetic induction. The grounded metal framework acts as a return path. Currents flow from the dome through the internal structure into the ground and back through the telluric current network. If you had the right configuration, the right size dome, the right grounding system, the right atmospheric conditions, you could generate a continuous small current. Enough to power lights? Maybe. Enough to charge batteries or run small electrical devices? Possibly. Enough to eliminate the need for a commercial power grid? No, the power density is too low. But enough to threaten the business model of utilities selling electricity? Absolutely. Because even a small amount of free power is competition. Here's what really bothers me about this. It's not that the technology might have existed. It's that the knowledge disappeared so completely. When the Roman Empire fell, we still knew how they built aqueducts. When medieval cathedrals were abandoned, we still understood the flying buttress design. When steam power replaced water wheels, we didn't forget how water wheels worked. But copper dome construction as an electrical technology? Gone. Completely erased from the historical record. Today, if you ask an architect why old buildings have copper domes, they'll tell you it's for aesthetics and durability. They'll say copper was chosen because it lasts a long time and looks prestigious. None of them will mention electromagnetic induction. None of them will talk about atmospheric energy harvesting. Or none of them will explain why the domes are grounded through metal frameworks. That knowledge isn't just lost. It's been replaced with an explanation that makes the technology seem like decoration. Let me show you something modern. Because atmospheric electricity harvesting never completely disappeared. In 2013, researchers demonstrated a device that harvests energy from the humidity in air using protein nanowires. It generates electricity continuously from water vapor. In 2020, scientists created materials that generate electricity from atmospheric moisture. They call it hygroelectricity. In 2023, a team built panels that can harvest atmospheric electricity at a rate comparable to solar panels in humid conditions. All of these technologies are treated as cutting-edge innovations, revolutionary discoveries, the future of clean energy. But what if they're just rediscovering what we already knew in 1800? What if copper domes were the original atmospheric electricity harvesters, and we've spent 150 years forgetting and then inventing the same technology? Here's the economic argument. Because this is ultimately about money. If every building could supplement its power needs with atmospheric electricity, even just 10 or 20%, the power grid industry loses billions in revenue. If people could install copper domes or atmospheric collectors without needing to pay for installation of power lines, utility companies lose control of energy distribution. If technology exists that provides free supplemental power, the entire business model of selling electricity by the kilowatt hour is threatened. JP. Morgan didn't pull funding from Wardenclyffe because it was impossible. He pulled funding because Tesla wouldn't tell him how to meter it, how to control who accessed the power, how to charge for it. Morgan asked Tesla, "Where do I put the meter?" Tesla couldn't answer, or wouldn't. The problem wasn't that wireless power didn't work. The problem was that it couldn't be monetized. So Wardenclyffe was shut down, the tower was demolished, and within a few decades, hundreds of copper domes across the world were removed, replaced, or retrofitted. Not because they didn't work, because they worked without meters. I want to be very clear about something. I'm not saying I can prove copper domes were free energy devices. I'm saying the evidence is consistent with that possibility, and the disappearance of the knowledge is suspicious. Here's what we know for certain. 1. Atmospheric electricity exists and can be harvested. 2. Telluric currents exist and carry electrical energy. 3. Electromagnetic induction is real physics. 4. Copper is an excellent conductor. 5. Historical buildings had copper domes with grounded metal frameworks, 6. Tesla was working on atmospheric power transmission, 7. Wardenclyffe was shut down and demolished, 8. Copper domes were systematically removed or replaced in the early 1900s, 9. The knowledge of why copper was used disappeared from architectural education. Those are facts. Here's the speculation. The domes were designed to harvest atmospheric electricity. They provided supplemental power to buildings. The technology was suppressed to protect utility monopolies. The 1815 Tambra eruption damaged a global electrical environment. Knowledge was deliberately erased. I can't prove the speculation. But the facts create a pattern that's hard to ignore. Today, copper domes are being restored on historical buildings. The Massachusetts State House dome was restored in 2016. The Library of Parliament in Ottawa got a new copper roof in 2008. The Arizona State Capitol installed genuine copper in 2021. But none of these restorations include the internal metal frameworks. None of them are grounded the same way. None of them are being installed with the understanding that they might have had an electrical function. They're being restored as decoration. Beautiful, prestigious, expensive decoration. And maybe that's all they ever were. Maybe I'm seeing patterns where none exist. Maybe copper domes were always just about aesthetics and durability. But I can't shake the feeling that we're rebuilding the hardware without understanding the software, putting copper domes back on buildings without knowing what they were designed to do. In 2025, researchers are still working on atmospheric electricity harvesting. They're building devices, running experiments, publishing papers, trying to figure out how to generate usable power from the electrical energy in the atmosphere. And somewhere in a library, there are photographs from 1850 showing massive copper domes on top of buildings across the world. Domes that were connected to grounded metal frameworks. Domes that were systematically removed over the next 70 years. Maybe those domes have something to teach us. Maybe the old architects knew something we've forgotten. Or maybe it's just coincidence. Maybe copper domes were always just decoration. And atmospheric electricity harvesting is a genuinely new technology we're discovering for the first time. I'll let you decide which explanation makes more sense. But I know this. When J.P. Morgan pulled funding from Tesla's Wardenclyffe Tower, he asked one question. Where do I put the meter? And when the answer was, you don't, the tower was demolished within 11 years. That tells you everything you need to know about which technologies get developed and which ones disappear. Free energy isn't impossible. It's just unprofitable. And unprofitable technologies don't survive in a world where energy is a commodity to be sold, not a resource to be shared. The copper domes are still there. You can see them if you look up. Beautiful green patina covering the roofs of our most important buildings. What they were designed to do, we may never know for certain. But the fact that we don't know, that the knowledge disappeared so completely, might be the most damning evidence of all.